Good morning and welcome back to Community Chat. My name is Joe Atkinson. I am the Communications Director for Evansville Mayor Stephanie Terry.
And I'm Taylor Maris, Special Projects Coordinator for the Evansville Police Department.
I think I wrote in something that you were the Special Projects Director. How do I get that wrong?
Because isn't Araya a direct?
She is.
Yeah. So that could be confusing.
Okay, I might have to fix that before we publish it because it's for a piece that's going out that the mayor's putting out. So okay. I might need to fix that. So I'm glad you just said that. Thank you, Taylor. That was very helpful.
You're welcome.
With us once again is Vic Kelson, the Executive Director of the Evansville Water and Sewer Utility. Thank you again, Vic, for being here.
Glad to be here.
Thank you for that explanation in the previous segment. And what I want to ask you now is, one of the things that we've talked quite a bit about is how much money this is going to save. The initial number that we talked about when you were kind of first exploring was about $100 million. Now we look at it and we say, actually, it's probably going to be a little closer to, up to about $200 million that's going to be saved. Where does that money come from? Where are we saving that money? Can you kind of quantify and explain that?
Yeah. So what we're planning to save right now is it's the incremental cost between building a new surface water plant and a new groundwater plant. Groundwater is much cheaper to develop. The plants are less expensive. You don't have to dig big holes and put tanks in them or any of that sort of thing. So they tend to be a lot cheaper to build. Perhaps, and we may get that done for $80 to $100 million instead of $140 or $150 million. So we were looking at what we expected was going to be close to $250 million to do improvements to the south plant and then building a new north plant. We think what we're doing right now is we're spending about $50 million on renovations to the south plant so we can reliably make the 24 million gallons per day. And we are anticipating the cost of the groundwater plant to be $100 million or less. So all in all, that's 150 instead of 250 that we'd be spending in capital costs in the short term to build the new plant. So that's where, when we talk about saving $100 million, that's what we're talking about.
So those first conversations, like when you spoke at Rotary and talked about, this is something that we're looking into, that was that $100 million?
That was that $100
okay.
million, yeah. And that seems to be panning out so far.
Okay.
But we've only now begun the design of the groundwater plant, and we'll be working on site selection and so forth. But the groundwater is cheaper to treat than surface water is. So if we find ourselves in 2 or 3 years where we're treating mostly groundwater, then our operating costs will also be lower. Mm-hmm. When we talked about building a plant that was going to cost $250 million, the rate case that was established expected that plant to be a lot less expensive than that. This was 5-6 years ago. Right. That rate case included $40 million for distribution system improvements, water main replacements, and so forth. We actually canceled or put all those projects on hold because, as Sean Wright's fond of saying, it doesn't matter if I can do distribution replacements if I don't have any water to put in them. So we need the plant first. Mm-hmm. So we were expecting that those projects would be canceled or put on indefinite hold while we built the surface water plant, and then eventually we might try to bring them back in a future rate case. We're hopeful that we'll be able to restore some of those projects as a result of going with this less expensive option.
Okay.
So the other $100 million is the fact that we knew very well that if we were treating river water for our entire distribution system, that if we were treating river water, we were going to have to build the PFAS plant, which is, in round numbers, it's probably $100 million to build that plant. It's a big operation. And then that adds additional operating costs. So all in all, that's when we talk about saving $200 million, it's part of its capital expenditures that we're going to avoid. And what that all manifests itself into is future rate case might happen later and be smaller. So we're not talking about, we save some money, we can just cut our rates. That's really not the way we operate because we're a utility. We always have things that needed to be done that we didn't get done for whatever reason. And water main replacements are really important, especially because we're ultimately going to have to deal with the problem of lead service lines in parts of the city. So all these kinds of things have to happen together, and that's the way we operate.
So the average person, when I get my water bill, I'm not going to see a sewer rate decrease because we're saving this, but more likely a year from now, 2 years from now, 3 years from now, you would have had to go and do another rate case to do those service line improvements and or to do the PFAS treatment. And that isn't necessarily going to have to happen at the moment.
Yes.
So that's where we're going to see, that's where I, as a ratepayer, will see savings, is that you're not going to have to jack up my rates in the near future.
That's right. The next rate increase will probably be smaller and happen later than it would have been had we had to treat PFAS.
Got it. And as a ratepayer, I'm grateful for that. So
Me and you both.
yeah, right.
And
How many different wells will there be?
Well, that's an interesting question. We estimate that a traditional vertical, we could call it a tubular well, you drill a pipe down into the ground. Those will probably produce right around 2 million gallons per day each. So
Okay.
you might need 8 or 9 of them.
Okay, that's
to
less
have
than I
extra
thought.
Capacity.
Actually, yeah.
That's the
So
most fascinating part to me, is how they get the water out of the ground.
Well,
I don't know why.
probably the most fascinating part to Vic too. So
Yeah.
well, and there's another technology. It's called a collector well, where basically you put a great big tank all the way down to the bottom of the aquifer, and then you push well screens out horizontally into the aquifer. You can make a lot of water from one of those, and the advantage is then you end up with one gigantic well, and you put more than one pump in it. So you just keep adding pumps until you reach the capacity of the well, and then maybe you put another one in. Those require larger sites and those kinds of things, but we can look at both and compare costs and benefits.
Do you already have the locations picked out, and are there better locations within the city that would have more water that's usable?
Yeah, there will be places where, for example, Riverside, there was the bottom 20 feet we drilled all the way to bedrock, and the bottom 20 feet was really coarse gravel, and the whole section was clean sand with coarse gravel at the bottom, so it was really productive.
And how far down is that?
About 110, 115 feet, yeah.
Okay.
So one of the questions that actually I was asked at United Neighborhoods the other night was, will all of those wells be on existing city property, or were we going to have to acquire any property or easements or anything like that?
At this point, we're focused on properties that we own, and because we need to blend this water, it's important to us that everybody drinks water that's of the same type. So when we talk about something like PFAS, and we acknowledge we have higher PFAS in the river water than we have in the groundwater, well, if we're going to blend it, we want to blend it for everybody. We don't want to have half the city get nice PFAS-free groundwater and the other half get river water that has PFAS in it. So that means that we'll want the treatment plant to be near the existing treatment plant so that we can put the blending station there, and everybody will get the same thing. So that ties it down a little bit, but we do know that we have several parcels in the area there that are really promising for groundwater development. So, it may not be 5 East Riverside, it may be somewhere else down there, but that general geography, and fortunately the utility owns a lot of land down there, so we're going to explore.
So the idea is that most of the wells would be down in that space as well. So you'd have your wells, you'd have your treatment plant, and you'd have that south plant that exists right now, kind of all in the same general vicinity.
That's really what we're shooting for, yeah.
Okay.
And eventually, if this goes well, and we just, once we've built the first one, and if we find really good quality and that it's cheap to treat, we could look at building another well field in another part of town. A lot of communities that use groundwater have multiple plants. Indianapolis has 8 or 9 of them. These kinds of things. So you put them where the demand is.
Sure.
And what that does is it does actually 2 big things. One of them is it gives you additional resiliency because you're not taking all your water from the same place. So if there's contamination flowing down the river from something that happened upstream, we just don't pump any surface water for a while while that's passing by.
Right.
Those kinds of things. The other thing that we get is less expensive infrastructure. So, for example, if there were some industrial development that was going to happen on the east side, and it would require larger distribution pipes to get there. Well, if we could build a few more wells over on the east side, we could get the water to that new development much less expensively than if we have to send it all the way from downtown.
Got it.
Similarly for the west side, if we have limited capacity and growing demand on the west side, there's a possibility that we could develop a source on the west side, and then we wouldn't have to build a giant pipe from the riverfront all the way over to the west side. So there's a lot of opportunities for us to save future capital expenditures by making good use of this resource. So, but first we got to do the first one.
Right.
So, and we can, once we do the first one, we can start thinking about what other things are possible.
And last question before we go to break, what is the timeline on this process? I know you've just gone to get approval of the bids for design through your EWSU board of directors. So what is the timeline now before we get to the point where we can start building and when we can start using groundwater?
We expect to be going out to bid probably late next summer.
Okay.
It's probably
That's for construction.
6 to 9 months to finish the design. Then we'll go straight out for bid, and then we'll do contracting for the actual construction. So I would anticipate that it's very likely we'll be in construction by the end of next year.
Okay. And so if I'm, again, as a customer, at what
Couple
point?
of years, probably.
Couple of years.
Yeah, it'll be a lot faster to build a groundwater plant than a surface water plant. And as the designs come forward, it may well be that we'll do the site assessment. We'll decide where the wells go. We can start building wells while we're designing the plant. There's nothing to keep that from happening. But
Okay.
that's all in the hands of the engineers. I'm not looking for that right.
Got it. Well, thank you. I'm not going to say that was the most important question, but that was the one that came from my wife. So I definitely wanted to make sure we got that one in. So thank you very much. When I get back, we have more questions for Vic Kelson about the groundwater plant here on Community Chat. So please stick around.